friends, hope you're doing well. Today I'm back with another project. I'm going to recover gold from these IC chips yielded from 32 motherboards that you saw. I processed pins from these motherboards with cyanide leaching in previous videos, and here I have IC chips from these motherboards. This is all black stuff which the soldered from motherboards, and you can see here we have transistors, IC chips, and even maybe some diodes. Everything, I have every black stuff which is on the motherboards from 32 motherboards, except for BGA chips that I want to process them separately in another video. And here actually I want to incinerate these chips because there is a thick epoxy here which is really compressed, and it is hard to be dissolved in hot sulfuric acid or wet ashing process. So I prefer to use direct flame or incinerating to process this, and also it is hard to dissolve transistors or MOSFET in sulfuric acid. So I need to first burn these out. Let's first weigh them up to see how much material we got here. These IC chips and transistors here is about 400 grams of material which is yielded from 32 motherboards. So let's start with incinerating to get gold. Alright then, all material converted to the ash, and now I want to crush them using a mortar and pestle. But just in case to release all gold bound wires into the ash powder, I decided to grind everything to the finer powder using a coffee grinder. Also, all copper base from transistors been separated in a screening process. At the center of copper base there is silicon die which gold bound wire is connected to it. So it's necessary to break silicon die to release gold bound wire completely. That's why I decided to use coffee grinder to break all silicon dies on the copper bases. This time, to wash ashes, I decided to use a gold pan to collect gold powder. I started with adding some dishwashing machine liquid. And as a result, I've got some heavy materials including copper wires, gold bond wires, and some big chunk of carbon. While I start transferring materials to a beaker to start processing, I noticed something. Gold bond wires were the last materials which came out of the gold pan, since they are much heavier than other materials. To start dissolving base metals, I've prepared some 13% nitric acid. I decided to use very diluted nitric acid since the IC chip's legs is plated with tin metal, and I just wanted to prevent formation of metastannic acid. Since dilute nitric acid convert tin metal to tin nitrate, I decided to trade small pieces of copper which was yielded from IC chips with nitric acid to see if there is any gold plating releasing into the solution. After treating materials for a while with dilute nitric acid, all tin content should be dissolved. After pouring wasted dilute nitric acid, I added some fresh concentrated nitric acid to dissolve remaining copper. When no bubbles were coming out of the solution, which means the reaction is completed, I've poured all used nitric acid into a jar to recover silver at the end. I could see gold powder at the bottom of the beaker after treating with nitric acid. I've placed beaker on the hot plate at the medium heat and I start adding some aqua regia to start dissolving gold. Gold dissolution completed, I cotton filtered solution and start washing cotton to the point which its color goes away and a stannous chloride shows negative test for a piece of cotton. After transferring solution to a beaker, I added some sulfamic acid to neutralize nitric acid. It is important to drop gold in clean glassware, otherwise gold powder will stick to the walls which is greasy from fingerprint. After addition of sulfamic acid, ferrous sulfate been added to drop gold and solution let sit. I've dissolved silver chloride yielded from nitrate solution in ammonia and filtered, and now I want to drop again using hydrochloric acid. Both solution let sit overnight to get precipitate completely. Gold powder and silver chloride both precipitated at the bottom and I've started siphoning solution on the top. Gold powder and silver chloride transfer to a smaller beaker to further processing. Now I want to turn silver chloride to silver powder. To do that I add some sodium hydroxide. Everything turn black completely, which is silver oxide. And to the gold powder I add some concentrated hydrochloric acid to start boiling and dissolve all impurities as much as possible. I place gold powder on the hot plate to start boiling, and here I've got silver oxide, all silver chloride converted. To turn silver oxide to silver metal, this time I want to use 37% formaldehyde solution to reduce silver. There we go, all silver oxide converted to the metallic silver. Then I washed silver powder several times with water to be prepared for melting. Since gold powder purity wasn't satisfactory enough, I added some bleach to redissolve gold again in hydrochloric acid and bleach mixture. I've added more bleach and placed beaker on the hot plate on the medium heat to accelerate the dissolution of gold. Again, some ferrous sulfate been added to drop gold again, this time with higher purity. To help with sticking gold fine powder together and precipitate much faster, I placed beaker on the hot plate in inclined position while steering turned on and set on the high. After half an hour, gold clump accumulated due to the vibration caused by hot plate. After washing several times with distilled water, gold powder placed on the hot plate to be dried, while blowing air from the top with a heat gun to prevent gold paste bumping. Afterwards, gold powder transferred to the crucible to be melted. Also, I did same to the silver powder. And finally, as the yield, this is gold yielded from that materials, 0.20 grams of gold or 0.19 grams of gold yielded from about 400 grams of material, which yielded from 32 motherboards, and it was mixed IC chip and transistor and diodes. Of course, diodes does not contain gold, but it was all material that I desoldered from 32 motherboards and processed them. And also I've got silver. This is about 0.30 grams of silver. And here I have copper. This was yielded from that transistors. I just wanted to weight this up to see how much of that material was copper, which total amount of 400 grams of material. And about 70 grams of that material, starting material, was copper. To be said, about total amount of 100 grams of that material was transistors, and about 300 grams of that material was diodes and IC chips. And this amount of gold is reasonable for that IC chips and transistors, I think so. So this video is done and we just finished another project. Hope you enjoy. Until next project, see you next time.